Assalamu alaikum. Dear learners, I hope you are fine and have watched the previous video in which I have discussed contact type level sensors. In this video, I am going to focus on contactless level sensors only, and we are going to see that these sensors are much more useful and can be used in any kind of situation in comparison to contact type level sensors. So without any further delay, the first level sensor that I am going to discuss is called ultrasonic level gauge. By the name of it, you can figure out that it is going to use ultrasonic waves to sense the level of the liquid present in any container. The working principle of this sensor is quite simple and straightforward and is very much similar to how an ultrasonic range sensor works. The ultrasonic transmitter will transmit some ultrasonic waves and they are reflected from the liquid surface and is received by the ultrasonic receiver. The transit time between the transmission and receiving of the ultrasonic wave is used for calculating the distance which the ultrasonic wave has traveled. And this distance can easily give you the level of the liquid present in the container. If you have viewed my video where I discussed that how ultrasonic range sensors work, then you can easily appreciate that it is exactly the same thing happening over here. In case of level sensors, sometimes ultrasonic transceiver is installed at the bottom of the container so that the ultrasonic wave is reflected from the liquid surface back into the liquid where the receiver receives it to figure out the level of the liquid. In this case, the whole container and the sensor comes as a single package. The fact that ultrasounds are reflected from almost every interface which they interact make them suitable for sensing the depth of such interfaces as well. In case where there are two immiscible liquids contained in same container, a setup shown in this schematic can be used to figure out the level of the liquid that is heavier and hence present at the bottom of the container. The ultrasounds emitted by the ultrasonic transmitter will be reflected from the interface of these two liquids and hence the height of the liquid present at the bottom can be calculated. This setup is also used to sense the amount or the height of the precipitate that has settled at the bottom of the container. So if there are any impurities or heavier particles present in any liquid, they will settle down at the base of the container and hence will reduce the overall capacity of the container. Therefore, periodic cleaning becomes quite important. Ultrasonic level sensors can be used to keep track of the amount of precipitate that has settled at the bottom and therefore can help in scheduled cleaning of the tanks. Although ultrasonic sensors looks quite well, but there are few considerations that limit the use of such sensors in particular environments. In the video where I talked about the ultrasonic range sensors, I said that the speed of the sound in the air or in any particular medium is very much dependent on the temperature of that medium. Moreover, the humidity, pressure, and the carbon dioxide concentration also affect the speed of ultrasonic wave in the concerned medium. Out of all these parameters, temperature is the most important one, as it affects the speed a lot more than other parameters. Therefore, sometimes only temperature compensation is provided, whereas other parameters are ignored. If we have to provide only temperature compensation, then it means we need a separate temperature sensor that senses the temperature of the environment where ultrasonic level sensing is being used. However, another more useful way is to use a separate ultrasonic transmitter and receiver placed at a defined distance to figure out the speed of the ultrasound in that environment. This method will take care of temperature, pressure, humidity, or any other environmental input that can affect the speed of the ultrasound in the environment. Another similar method utilizes microwaves instead of ultrasonic waves. However, it is much more expensive than the ultrasonic level sensors. The radar or microwave level sensors have few advantages over simple ultrasonic level sensors. First of all, these sensors can be used with sealed containers, unlike ultrasonic sensors, because microwaves can easily pass through the wall of the container. Secondly, they can measure the level of the liquid even if it is in a turbulent form. Moreover, the presence of the vapors above the liquid surface in a sealed container will not affect the reading generated by this sensor. Last but definitely not the least, or perhaps the most important one, is that the propagation of microwaves in any environment is not dependent on temperature, pressure, or humidity of that environment. Now, this was a major problem for ultrasonic sensors. The working principle of these sensors is quite simple. The microwave source transmits the microwaves in multiple directions. The detector will detect a direct signal from the transmitter and one of the reflected microwaves which is being reflected from the surface of the liquid. Other microwaves that are being reflected will not enter the detector and hence will not be taken into account. The reflected microwave will definitely have its phase shifted because of the reflection, and a comparison between the phase of the original signal and the reflected signal will give us the level of the liquid present in the container from which the reflection is coming. One consideration that should be kept in mind while using microwave or radar level sensors is that microwave frequency is within the band used for radio communications. Therefore, licenses should be acquired from the concerned authorities before using these sensors, and the power level of microwaves should be minimized to avoid any interference with the radio communications. Moving on, we can sense the level of the liquid present inside any open or sealed container using radiations as well. A radiation source installed at the bottom of the container will transmit radiations through the liquid towards the radiation detector. The level of the liquid present in the container will dictate the amount of radiations being received at the detector, because the more the liquid present in the container, the more it will absorb the radiations, and hence less radiations will be received at the detector. If we have a sealed container, then we can directly install the source and the detector in a vertical direction. Whereas if it is an open container, then the length of the liquid or the level of the liquid which the sensor will sense will not be the vertical level, but a diagonal level. And hence some trigonometric manipulations should be done to get the vertical level of the liquid present in the container. The downsides of these sensors include the high cost and special arrangements for shielding and protection that should be used while using these sensors. The last contactless level sensor that I am going to discuss has a similar working principle as that of ultrasonic or microwave level sensor. However, instead of ultrasonic or microwave, we are going to use a laser light. The laser light directed towards the surface of the liquid will get reflected from the surface and will be detected by a CCD array present on the other side. Only one of the CCD element will detect the reflected light, whereas other CCD elements will not receive anything. You can think of it as the CCD array is generating an image and there will only be a one bright spot at a particular point. As the level of the liquid inside the container changes, the position of the CCD element which is receiving the reflection, or the position of the bright point in the image that the CCD array is generating, will tell us the level of the liquid present in the container. If we are using visible laser light, then this setup is of course not suitable for sealed containers. Therefore, we can use IR radiations if level of liquid inside a sealed container is to be measured. This was everything about contactless level sensors that I have to talk about. I hope you have understood the basic working principles that are involved in various kind of contactless level sensors that are being used in industries all around the world. Thank you and take care.